In this video, I would like to explain you one of the another um a very simple question, but most frequently asked to a data scientist and and interviews for different kind of at different level, basically for data scientist or senior data scientist at any level. This question might be asked because this will check your fundamental understanding of your basic machine learning principles. So the question is, what is the difference between correlation and covariance? So the question, let me try to put it down. So what is the difference between correlation and covariance? Covariance. So what exactly is correlation? Correlation is nothing but it will give you strength and direction of the relationship between two variables. So suppose you have two variable and you wanted to understand and how one variable is dependent on another variable. For example, let's take example that okay, there is a student and a student which studies like X is nothing but number of hours he studies. So suppose he studies 5 hours, 8 hours, 9 hours, and 10 hours a day, and y variable is nothing but how much score he is getting. So when he studies 5 hours he's getting 50, and 8 hours likewise he's getting 60, 70, and for 10 hours he's getting 90 marks in an exam. So I wanted to understand what is the relationship between these two in terms of understanding, like if you study more, is there a chance to get more scores? Uh, this is what I'm trying to understand. So, yeah. So for that, we use correlation. So correlation basically measures two things. One thing is it measures the strength of relationship, strength of relationship between two variable, and this relationship would be a linear relationship. Another thing which it gives is direction of the relationship, and direction can be positive and negative as well. So in this case, if we try to plot this x and y, what will happen? Suppose x is in x-axis and y is in y-axis. We try to plot, we will try to get some kind of plot, something like this, which is kind of linearly increasing. So the direction is positive, and strength we can strength of this relationship we can measure with the help of correlation formula. So we can try to measure the strength with the help of correlation formula. So maybe I'll just try to write down the correlation formula. So if you want to um, get the correlation, then you can use this formula. It is nothing but covariance x and y and standardized form of basically covariance, which is uh, standard deviation of x into standard deviation of y. I'll not go too deep in this. I'll explain it later. So you can see. So basically, the range of correlation would be from -1 till +1. So wherein -1 will say that okay, if one variable is increasing, another variable is decreasing, and which means that there is a linear relationship, but in negative direction. So and +1 is perfect positive linear relationship, you can say. In -1 you can say perfect linear negative linear relationship. So for positive correlation, you saw the example here that okay, the more you studies, the more marks you can get. So for negative relationship also, I can give you an example. Like suppose you drive a car, and the car is full tank, and once you started driving at first hour there was 10 liters of petrol, and likewise the more you drive and the petrol reaches till zero. So there is relationship between number of hours you drive the car and at the same time the petrol consumption, but it is kind of in negative direction. One, if the value of one variable increases, another variable decreases. So and in this case, it would be a kind of negative relationship, negative linear relationship between these two. So this is about correlation. It gives measurement. It is being used to understand the strength and relationship between linear relationship between two variables, and it gives two things. It gives strength, at the same time it says that what is the direction of the relationship, whether it is positive, negative, and it is dimensionless, so there is no dimension attached to it, and it the range varies from -1 to +1. So suppose two variable you are trying to analyze, and if the correlation is +1, it is like perfect positive linear relationship, or -1 says that perfect negative relationship, and value in between this can be anything. So zero, other value is zero. Zero means there is no relationship between, no linear relationship between these two variables. This is about correlation. Now let's come to the covariance. Even covariance are used to basically to understand the relationship between two variables, but it only gives what? It only gives the direction of the strength, direction of the relationship. So it only says what is the direction. Suppose in previous example, if you study more and do are you getting more marks? So that is kind of direction to understand, like uh, if you increase one variable, where the another variable is going. So it can be of two type. So it is basically of two type. The first type is positive covariance. Another type is negative covariance. Positive covariance say that okay, uh, if you increase one variable, another variable is also going to increase. Negative covariance says that gives only the direction that okay, if you increase one variable, another variable might another variable will definitely decrease. So the formula to calculate the covariance is, suppose we have two variable x and y, covariance can be calculated with the help of this formula. Covariance of x of y is equal to 1 upon n minus 1. So n I'll explain in a bit. I 1 to n x of I minus mean of the x, and y of I minus mean of the y. This is the formula we use to calculate the covariance, where x is nothing but we can try to take this example. Suppose um, x is some values, number of hours of study 1 2 3, and y is also marks like 5, 10, or 20. And this xi is the mean of this. You can calculate the mean of this, and you can calculate mean of y and try to put the values here, and you will get the covariance of that. So now the final difference, if I have to uh, explain you the final difference between these two, would be so correlation and covariance. The first difference would be it gives a strength and the direction of linear relationship. Linear relationship, it only covariance only gives the direction of linear relationship. Direction of linear relationship. Okay. Another difference would be it is dimensionless. 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 It because it does not have any units, but here it has some unit. Has some unit. Like it would depend upon the it will depend upon both the variables among which you are trying to figure out this. These are the two differences, uh, and the value here, value might range from -1 to +1. Here value can be anything. It would depend upon the values of the variable. Value can be anything here. So this is the difference between uh, correlation and covariance you can explain to your interviewer. Thank you.